All right, so we're gonna do this. Key. So I'm just gonna go take this like I were taking a quiz. This is an old quiz, but it was made into a breakout. So you can kind of see my thought process along the way. So I'm gonna read the question to make sure I know what I'm answering. So dominant intermolecular force. That means so all molecules have London dispersion forces. So the only way I would circle or select London dispersion forces is if I was a nonpolar molecule or if the molecule is nonpolar. There's every other interaction, A, B, C, D, and E, would be a stronger interaction than the London dispersion force interaction, and that would be the dominant interaction. And you wouldn't have more than two London dispersion forces in one of the others. So, all right, can be used more than once or not at all. Oh, that makes it hard. And there's the pure solution or solid. Okay, so Br2 is nonpolar. So the only interaction that it can have is London dispersion forces. We have NH2CH3. That's going to look a lot like NH3, where we have the lone pair, and then we have two hydrogens, and then one CH3 group here. So this is definitely going to be a polar group. And you'll notice that because we have an NH2, we have a nitrogen attached to a hydrogen, and then we have another nitrogen with a lone pair. So not only is this going to be polar, it's going to allow us to do hydrogen bonding. So that's going to be D, again, because hydrogen attached to a fluorine, a nitrogen, oxygen can hydrogen bond. Lithium fluoride, that is a metal, lithium, a non-metal, that is a ionic compound. So again, just remembering from our first unit definitions of ionic compounds. So it's going to be ion-ion interactions there. Next is a hydrocarbon. There are only carbons and hydrogens. That would be a nonpolar molecule. So nonpolar is always going to have London dispersion and nothing else. And then the last one, we've taken methane, we replaced it with a chlorine, so that's going to be polar. And if we just draw that one out, we can see that if I put the chlorine here, that we have, we're going to have a slightly negative chlorine kind of in this region, and then, I'll fix that, and then slightly positive here, where this is a hydrogen. So this is going to be polar, so it makes a dipole interaction. The only one we didn't use was an ion dipole. That would be something like NaCl aqueous, where the ions are Na plus and Cl minus, and the dipole would be H2O. Next, circle all the following that you predict would increase the strength of intermolecular forces between two ion. Let's read this again. Circle all of the following that you would predict to increase when we increase the forces between two ions. Man, who writes these things? Okay, so we have the IMFs between two ions increases. Then we know that it's going to be harder to melt those, because to melt you have to break those interactions. Lattice energy is another measure of ion-ion interaction strength. Delta fusion is the amount of energy that it takes to either go melt or to go into a solid form. So that should also increase. Bond length, the stronger the interaction, we would expect in all cases the bonds, everything gets closer together. So bond length would actually decrease, not increase. And then the last one, circle a molecule that is the highest boiling point and provide explanation. So I noticed that this has 4 carbons. If I'm just looking at size, and here I have 1, 2, 3, but I have 3 of these CH3s, so I actually have 6 carbons and more hydrogens. And so because this is the larger molecule, then we're going to say that molecule, this has the higher boiling point because it is larger, which means it has more electrons. So the London dispersion forces will be greater. Now, even if this molecule that kind of looks like 1, 2, and then 3, and then branch, 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 even though it kind of looks where the other one looks like this, um, the size matters more than shape. If you have that big of a difference in size, then shape does not affect it as much. So that's why we first look at size, number of electrons, and then look at shape. So hopefully that helps. And yeah, there you go.